The spleen. The spleen is a lymphoid organ. That means it consists of a lot of different lymphoid tissues in it, and hence naturally it is associated with two main functions, phagocytosis and immune response. It helps the body to fight against pathogens and helps to maintain the immune response inside their body. Now, you might think that the spleen is quite important now because, of course, it is playing such an important role, but it's not really that important. If, for example, if a person's spleen is dissected and taken out, the person will be able to survive. So we can say it is mononuclear phagocytotic. But there are many different organs inside our body that are mononuclear and phagocytotic. For example, the liver. So if the spleen is removed from our body, it will not necessarily mean that the body will be at a great loss. There will be compensations which are being done with the help of different organs that are also mononuclear phagocytotic, for example, the liver. In the embryo, the spleen acts as a center of homeopoiesis, that means the making of the red blood cells. In the adult, it's a different case because in the adult, there is, in a normal functioning adult, it's the bone marrow that helps in the making of the blood vessels. But in the embryo, the site of homeopoiesis is the embryo. In the embryo, the site of homeopoiesis is the spleen, sorry. So let us look at the spleen and let's determine how big it is in a normal human being. In a normal human being, the length of the spleen ranges from 9 to 14 centimeter, the width ranging between 6 to 8, and the thickness about between 3 to 5 centimeter. There are a lot of organs in the vicinity of the spleen, so we can say that the shape does not really stay uniform in different individuals. It's just like a massive blob of organ parenchyma. It's a blob of like it's really shapeless. It depends like what sort of organ is shaping it. So if a person is tall, if a person is short, the spleen will vary in size. The next thing you can see is that the spleen is located strategically inside our body. It is located in the left hypochondriac region. That means hypochondriac meaning hypo or below the chondrus or the ribs. So hypochondriac, this hypochondriac organ, it's really, you can see that it's really inside the it's really under different organs. So here there is the colon, the splenic flexure of the colon right here, and then we have the diaphragm that's on the top of it. So these are the anterior surface and the posterior surfaces of the spleen. Now notice the fact that I have clearly mentioned which is the medial side and which is the lateral side of each surfaces respectively, because both of the surfaces have different lateral and medial side. Ranging from the posterior surface, the medial side is on the towards the left side, and this side here is towards the right side. So that's the vertebral column, keep that in mind. So let us look onto the surfaces of the spleen. So the surfaces are in coordination with the organs that are found around the spleen. So the first organ that we're going to be looking at is the diaphragm. And diaphragm is found in the superior aspect of the spleen, and hence the splenic surface that we're going to be looking is known as the superolateral diaphragmatic surface. Now you can notice that most of the diaphragmatic surface encompasses the posterior portion of the spleen right here, and a little bit of it is also present on the anterior side, but mostly the posterior side. Now, the next surface is known as the inferomedial surface. Now, inferomedial surface is also known as the visceral surface because here we're going to be seeing a lot of impressions of the organs that are in close vicinity with the spleen. Then, let us look at the borders. Starting from the first, we can see that there is the anterosuperior border. Now, anterosuperior, that's why I've only marked this on the anterior surface of the spleen. Then we have the other border known as the inferior border, the posterior inferior border. After that, we have the two poles. The first pole is known as the superior pole, and then we have the inferior pole. Now notice here too I have mentioned two different poles on the basis of their surfaces. The inferior pole is on the anterior surface, however, The superior pole is on the posterior surface. So for a better understanding, let us look at the position of the spleen with respect to the diaphragm. So that right there is the anterior surface of the spleen, and you can see how the diaphragm usually covers most of the posterolateral region of the spleen. So if I just take off the diaphragm here, you can see how the anterior portion and the posterior portion is inclined with respect to the vertebral column. And next thing is that if I'm going to just add all of the organs right here, all the different organs of the digestive system, you can also still notice how the spleen is associated with them. So yeah, right there. You can see how the spleen is posteriorly placed, most posteriorly placed, and how there is, because we're going to be learning about the impressions of the spleen right now. You can see that there's the pancreas that's in close association. Now, inferiorly, we can see that there is the presence of flexure, the splenic flexure of the colon, and then we have the anterior superiorly, we have the fundus of the stomach that's in close association here. So let's look at the impressions. The impressions are more and more concentrated towards the visceral side, especially the anterior visceral side of the spleen, because we know for the fact that posteriorly we just have the diaphragm and there's nothing much to say about the posterior aspect. But on the anterior aspect near the visceral side, we can first observe that there is the gastric impression. Now, the gastric impression, as I mentioned earlier, is formed by the greater curvature, the fundic side of the stomach, especially near the greater curvature of the stomach. Then we have the colic impression. Colic impression is found by, of course, the splenic flexure of the transverse colon. Then we have the renal impression, of course, that formed by the left kidney. Remember the fact that the left kidney and the superior pole of the left kidney. Then we have the splenic artery. The splenic artery is a tortuous artery that comes off of the abdominal aorta and goes all the way across the length of the spleen and pierces the hilum of the spleen, creating an impression right there. Then we have the last impression known as the pancreatic impression, especially the tail of the pancreas. The pancreas is quite long and it traverses laterally and goes all the way and pierces the tail of the pancreas. The tip of the tail goes and sort of nudges itself near the hilum of the spleen. So in total, we have 5 impressions: gastric, colic, renal, splenic, and the tail of the pancreas. All right, now let us take a look on what are the ligaments that are in close association with the spleen. Because the spleen is the organ that is situated in the abdominal cavity and it has to be attached to something. There's no bone to it, there's no any specific attachment to it. So the way it is attached to the abdominal wall is with the help of other organs that are in close vicinity to the spleen. So the first thing to consider is the fact that the entire structure is covered by the visceral peritoneum. So it's completely enclosed by the visceral peritoneum. And next to that, we can see that it has a lot of ligaments too. The first ligament that we're going to be seeing here is known as the gastrosplenic ligament. So the gastrosplenic ligament, as the name suggests, connects the upper pole of the spleen with the stomach, especially the upper pole of the stomach. Then we have the other ligament, known as the splenosphenic ligament. The spleno in the name means spleen, and phrene means diaphragm. So it connects the upper pole of the spleen with the lower aspect of the diaphragm. Then we have the splenorenal ligament. Now, the peculiar thing to know about the splenorenal ligament is that it has 2 extensions, 1 and 2, one of which connects to the colic part or the transverse mesocolon and transverse colon. Especially, we know that in the inferior portion we have the splenic flexure of the transverse colon, so that's where this part connects. And then we have the other part that connects to the kidney, to the renal area. So that being said, it also originates from the inferior pole that is found on the inferior border of the spleen. Next thing to observe is the fact that the other ligament is known as the splenocholic ligament. Along with in conjunction to the splenorenal ligament, we have the splenocholic. Now, splenocholic, as the name suggests, to the colon, the transverse colon. And then, lastly, we have the phrenocholic ligament. Now, this is one of the large ligaments right here that connects the upper pole and the lower pole to the inferior portion of the diaphragm, like a really strong hold. So the first pole, the first area, or the first extension of this ligament is in conjunction with the gastrosplenic ligament, because they are like almost fused. And the inferior part of it is the one that's going to connect to the colon. And all of this entire structure is going to be adhered to the inferior portion of the diaphragm. So let us look at the arterial supply of the spleen. So we know that the abdominal aorta is the one that comes off and supplies most of the organs of the abdomen. So the parenchyma of the spleen is supplied by the celiac trunk of the abdominal aorta. And then coming off of the celiac trunk, we have the two polar arteries. Sorry, first we have the splenic artery right here. So I'm just going to add a small minor detail. So that's going to be splenic artery. Now the splenic artery is a tortuous artery. As you can see, the artery that's projecting like this and going inside here is known as the splenic artery. So after the splenic artery, it goes and divides into the two portal artery. So you have the superior and the posterior portal artery, and these portal arteries go and give off segmental arteries inside the parenchyma of the spleen. These segmental arteries then give off follicular arteries, and follicular arteries are usually surrounded by an array of lymphoid tissues and lymphoid vessels, etc., etc. Okay, so that right there is how it is formed. That's the celiac, the spleen, the splenic, and then the division into two polar and then the segmental arteries. Okay, now let us look at the venous supply. The venous supply, we're going to be looking at it from the bottoms up, because last time, when we spoke about the arterial supply, we spoke about how it goes on, how the vessel keeps on branching out, branching out, branching out until the end it releases follicular arteries. So from here it's the other case. The most smallest vein that comes off of the most superior branch is known as the tuberculate vein. Now the tuberculate vein goes and converges to form the segmental vein. The segmental vein goes and converges to form the lobar veins. The lobar veins come together and give rise to the splenic vein. And then lastly, the splenic vein merges into the superior mesenteric, which lastly goes into the portal system. It's quite easier to observe it in this atlas right here. So those are the veins, those are tuberculate veins, and then they go on and form the segmental, the lobar, and then the lobar comes and forms the splenic vein there. It goes and merges with the superior mesenteric artery, which goes into the portal vein here, which goes and supplies into the liver, and it gets taken up by the inferior vena cava. Let us look at the splenic microstructure. The splenic microstructure is quite different from the other organs. We know that the spleen is a lymphoid tissue, more of a lymphoid tissue than an organ, and the parenchyma is rich with lymphocytes and different components which are quite different from other types of organs that we saw earlier. So it is composed of lymphoid tissue mass, and then we can say that the tissue is divided into the red and the white pulp. So that's like a cross section of a typical spleen, and you can see that exteriorly the most superior portion of the microstructure of the spleen is composed of the serosa. The serosa of the spleen is about 1.5 millimeter in length, and it is composed of connective type of tissues, namely the elastin and the collagen fibers. Now the elastin and the collagen fibers extend into the parenchyma of the spleen, making projections. As you can see that these projections right here, they extend all the way into the white and the red pulp. And these extensions are made up of connective tissue type 3 reticular collagen fibers. Then let us take a closer look onto the red and the white pulp. The red pulp and the white pulp. So the structure that you can see in light pink is known as the white pulp, and the one in dark pink is known as the red pulp. The white pulp makes up about 5 to 20% of the total splenic parenchyma, but the red pulp makes up the majority of the 95%. Now let us take a closer look into the red pulp. The red pulp right there is supplied by, of course, branches of the splenic artery. But approximately at this region, at the region you can see right there, this small region, something happens, a small change happens. We know that most of the arteries are supplied, like they have an adventitia or covering of connective tissue outside. So the connective tissue at the end of the splenic artery, the last branch of the splenic artery, that might be the trabeculate artery or the follicular artery, there's a change which leads to the formation of there's a change in the fascia of the or the serosa of this splenic artery, which leads to the aggregation of the T type of lymphocytes in this area. And then this thing expands, it expands and expands and forms a pals or periarteriolar fascia, a thick periarteriolar fascia that is visible to the naked eye, which is composed of a lot of different types of lymphocytes. And mostly the first two aggregates that we can see here are the B lymphocytes and the T lymphocytes. Now, looking at the red pulp, we can see that it has a lot of venous sinusoids in it. Now, venous sinusoids are are portals to the venous system of the spleen, because we know that the main job of the spleen is to get rid of the erythrocytes that are found, the dead erythrocytes that are found here. It's like a filter, so it's provided extensively with venous vessels that go and drain all of the stuff that we don't want. So these are known as the venous sinusoids, which are about 50 micrometer in length, like the diameter is 50 micrometer, and they go into the splenic veins. They merge into the splenic veins. Then we have something known as the reticular connective tissue. Now, reticular connective tissues are just connective tissues that are found near the sinusoids. Then we have something known as the staph cells. Staph cells are plank-like, bear-like cells that are found around the venous sinusoids, and there are slits between these cells, so that they contribute to the discontinuity of the endothelial lining and also endothelial lining of the venous sinusoid, so that they can act like a sieve, so that the erythrocytes can squeeze through them. Then we have something known as these cells, which are the stellate fibroblast cells. Stellate fibroblast cells have a main job to basically contribute to the connective tissue connective tissue mass inside the splenic parenchyma. So all of the connective tissue that you find around it is formed by the fibroblast cells. Then we have the macrophages. Macrophages, of course, because the dead erythrocytes are eaten by the macrophages. There's an area that is found around the white pulp of the spleen, known as the perifollicular zone. Now, as you can see there, that's the artery. This right here is the artery. The artery goes and it enters the white pulp, where it becomes tuberculated. Then this tuberculated artery, it becomes penicillar. This penicillar artery goes and traverses through the white pulp into the red pulp. It reaches the splenic cords and then reaches to the venous sinusoids that are found in the red pulp, and then it percolates and drains into the venous sinusoids. And all of this drained blood, which is filtered, is carried out to the other side of the system, known as the infravena cava, through the portal vein.